Hi, everybody. We're looking at the Yearly Review 6, Worksheet 6. And so we're going to take a look at a few problems here. I'll get as many as I done as I can here in this first video. So let's take a look at number 3 from today's assignment. Order the following from least to greatest. And we have some of these are written as fractions. Some of these are written as decimals. These are all called rational numbers. Rational numbers. Ooh, that's large. I need to shrink that down a little bit here. Yeah, these are all rational numbers. And we need to be able to compare rational numbers and get them in order. We're going to go least to greatest here. One of these is clearly larger than the others. 5/8 is like part of something. 0.6 is part of something. 0.7 is part of something. 5/2 is more than the entire thing. That's an improper fraction, 5/2. So of these four, I immediately know 5/2 is the largest. So let's just pull that one right out. 5/2 has to be the largest. I'm looking at my answer choices here. It is multiple choice. 5/2 is the largest in A and in B, but all of a sudden C and D, we have 0.7 listed as the largest. We know both of those are wrong. I already know my answer has to be A or B. And I haven't even hardly done anything yet. So anyway, how am I going to compare these? The easy way to compare these is to change them all into decimal form. Two of them already are listed as decimals, 6/10 and 7/10. So how do I change 5/8 into a decimal? Well, fractions are always division problems. We can divide 5 by 8. I can do this by hand. You could probably use a calculator on a problem like this also. But 8 times 6 is 48. We have a remainder here of 2. Bring down a 0. 2 times 8 is 16. We get a remainder of 4. Bring down another 0. And 8 times 5 is 40. So we're going to get our remainder of 0 there. So 0.625 has the same value as 5/8. Well, this is showing through the thousandths place, 625 thousandths. So I'm going to show my other ones through the thousandths place also. So this would be 0.600. Just add a couple zeros. Same thing here. You can write 0.700. 5/2, just so you know, if you divided 5 by 2, you'd get 2.5. That's obviously way larger than the rest of these. So which is the smallest? Well, 0.600 is less than 625, which is less than 700. So 0.6 is the least. Boom. This one starts with 5/8. 0.6 is the least, followed by 0.625, which is 5/8, followed by 0.700 or 7/10, and then 5/2 is your largest. So again, change them all into decimal form, then you'll be able to compare them to each other. All right, number 7, which circle graph shows the data correctly? We have a table here that shows miles walked, and we have A, B, C, D. That must be 4 different people, and the number of miles each of them walked. A walked 7 miles, B walked 3 miles, and so on and so forth. If you total these all together, 14 plus 4 plus 3 plus 7, 7 and 3 is 10, 10 and 4 is 14, 14 and 14 is 28. We need to total that up. And the reason we need to total this up is because I need to know what each of these individual numbers here represents of that whole amount of 28. You know, I look at 14 out of 28, for example. That's exactly half of the total. So this is 1/2 or 50% right here. 7 out of 28, see here, this was 14 out of 28, which is 1/2 or 50%. 7 out of 28, isn't that 1/4? 7 does go into 28 4 times. So if that's 1/4, that would be 25%. All right, this one's 3 out of 28. This one's 4 out of 28. Don't worry about those so much right now. 4 out of 28 is 1/7 if you simplify it. But these two right here are really important. A at 25%, D at 50%. That tells me I need a circle graph that has a section that's 50% of the circle or half of the circle. And I see B and C both have a section that would represent 50%. 50%. So in either one of those, that would be D, wouldn't it? D, 14 out of 28 is 50%. A doesn't have a section that's 50% or half. D doesn't have a section that's 50% or half. So I already know it has to be B or else C. Now I also know since there's 7 out of 28 or 1/4 here, I need a circle graph that has a 25% section, which would be 1/4 of the circle. And if you look at B, doesn't this section right here look like it's 1/4 of the entire circle? We have a right angle here. That's 25% right there. That's good. Do we have a section over here that looks like 25%? Maybe. I mean, this section right here might be 90 degrees. It looks like it's a little less than 90 degrees. So maybe I'll put a question mark there, but I'm not convinced on that one. That looks like it's less. Like if it were 90 degrees, it would be more like that, wouldn't it? So I think C, we'd be safe eliminating that one. Now these other sections are pretty close together. B and C are pretty close together. One's 3, the other's 4. This looks like it's smaller than this, so this must be the 3 and the 4. It would be here. Okay, this here would be the 7, and up here would be the 14. But definitely that's the circle graph that would match this data here. And so how did I find that? By figuring out what part of the whole these are and looking to see, well, is there a circle graph that would match having a 50% and a 25% section? Okay, so definitely B would be the one that would match best. All right, number 8, what is 45% of 0.6? Whenever you're finding percents, these are multiplication problems. In math, the word of means times. Of means multiply. So we're multiplying by 0.6. What are we multiplying? Well, 45%, we need to change this into decimal form. And you do that by moving the decimal point to the left 2 spaces. Where is the decimal point? I don't see one. Well, that's because it's a whole number. So the decimal point has to be at the end of the number. To change it to a decimal, move that decimal point left 1, 2 spaces, and it's 0.45. So to find 45% of 0.6 or 6/10, you have to multiply 0.45 by 0.6. When you're multiplying numbers like this, you don't have to line up the decimal points, okay? You can put the 6 right under the 5. 6 times 5 is 30. There's my 0, carry the 3. So right now I'm just multiplying, ignoring the decimal points. 6 times 4 is 24. Add 3, that's 27. Now what I'm noticing here is the decimal point here is in 2 spaces, and here it's in 1 space. So that's a total of 3 spaces that are in the decimals. So I'm going to move in 3 spaces, 1, 2, 3, and place my decimal point. So I have 0.270. And by the way, I don't have to show the 0 on the end. So my answer is 27/100. All the cool cats would put a 0 out in front of the decimal point as well. So 27/100 is our answer for number 8. Okay, number 14. Brock measured the length of his driveway with a tape measure. It is 288 inches long. How many yards long is his driveway? So all I need to do here is take 288 inches, convert it into yards. Okay? Now you might not know how many inches are in a yard. If you do know that 1 yard equals 36 inches, then you're in business. All you have to do is take 288, divide by 36, and you're going to have your answer. You'll be done. But what if you didn't know that 1 yard was 36 inches? Hopefully you know that 1 yard is equal to 3 feet, right? There are 3 feet in a yard. And I bet you know that 1 foot is 12 inches, right? So if you have 3 feet in a yard and each foot is 12 inches, then you have 12 times 3, which is 36 inches in a yard. So you can kind of walk your way up to that conversion by doing that right there. All right, so how many times does 36 go into 288? It won't go into 2, it won't go into 28. It does go into 288, but I mean, how many times? It'll be 8 times. See, 8 times 6 is 48. See how that ends in an 8? Carry the 4 here. 8 times 3 is 24, plus 4 is 28. Yay! It matches. I get a remainder of 0. So 288 inches equals 8 yards. We have to divide by 36 to make this conversion because there are 36 inches in 1 yard. Number 15, a $26 football is on sale for $20.80. So this right here is your original price, or you could call it the regular price, right? And this here is your sale price. What is the percent off of the regular price? What we have here is a percent change problem. And in order to find the percent of change, you first have to know what is the amount of change. In other words, how much of a discount do we have? How much money was taken off of the original price? And then you divide that by the original amount. Okay, so the amount of change is what we get when we take $26 and we subtract $20.80. You can use a calculator for this. It comes out to $5.20. So the amount of change is $5.20. Whoops. $5.20. And then we'll divide that by the original amount. Well, the original cost was $26. And you can use a calculator to do this. And when you do that, you're going to get 0.2 for a result. Okay, it equals 0.2. But we want to know what is it as a percent. This is our decimal. Move 2 spaces to the right. We fill this space with a 0. It looks like it's 20% off. So it was a 20% discount on that football. All right. Okay, so that's all I have time for in this video. I'll do another video for the numbers 15, 16, 18, or numbers 16, 18, and 22. All right, I'll see you later.